It's actually just over 2 weeks before that eclipse in August is our 25th wedding anniversary. So we're going out before our anniversary and coming back after the eclipse. So we'll celebrate both.
Yeah, I was like, and then I was like, oh my God, this is really happening. And before I knew it was over, it was sad. This is crazy. This is so nuts.
I'm Leticia Ferrer.
And I'm Chris Alexander.
And this is Totality Talks, the solar eclipse podcast.
It just took my breath away, the whole thing. It's really cool that you can see the corona and you see the sun kind of spewing out from behind the moon. It literally took my breath
Welcome back to Totality Talks. In this episode, we welcome Dr. Angela Speck, Professor of Astrophysics and Chair of the Department of Physics and Astronomy at the University of Texas, San Antonio. At 4 years old, she dreamed of becoming an astronaut. And while not scheduled to fly, she has continued to vigorously study the untold secrets of the cosmos. The English-born professor has become a leading eclipse expert, having first helped prepare the U.S. public and media for the total solar eclipses that took place in 2017 and 2024. We welcome Angela to the podcast. So, we have Dr. Angela Speck from University of Texas, San Antonio, astrophysics professor and astronomy professor. We got to know Angela over the last eclipse. We met her at the American Astronomical Society Solar Eclipse Task Force meeting. And we welcome you to Totality Talks. You'll be our second version of a video version of our podcast.
Excellent. I'm excited.
So, how are you doing today?
Doing all right. I mean, it's the proposal deadline season.
Ooh. Is that why you're not teaching classes this semester? You kind of said
so actually, I was department chair until September 1st. And one of the things they do when you step down from being chair is they give you sabbatical, essentially. So I'm on sabbatical this year. Yes.
That's nice.
Very nice.
That's an incentive to be department chair and put up with everything.
It's a lot being department chair. So you really need the time to recover.
Yeah.
So how about give us a little bit about your personal background and also then your journey to your first total solar eclipse.
So I'm originally from Yorkshire in the north of England. For those people who know who Fred Hoyle was, he was actually an astronomer royal in the UK and quite famous for promoting like panspermia and things like that. But he grew up in a mill cottage in the shadow of a big textile mill, 5 miles from the cottage that I grew up in the shadow of a textile mill. So, that's kind of the early years. And I decided when I was 5, I was going to be an astronaut. So, obviously I wavered a little along the way and thought about some other careers, but essentially went back to it when it was time to apply for college, and then went to college in London to major in astrophysics. And that's how I got myself started. Now, my first of any type of eclipse that I saw was 1982. And it was only a little bit of an eclipse. I don't remember the exact percentage, but maybe 20%. And I went out to the local park and with a dustbin liner, a trash bag, because, I didn't know any better, and went and watched it. And I would have been 11-ish at the time in middle school. And it was amazing. And I knew even before that, the first total solar eclipse that was going to happen in the UK in my lifetime was in 1999. And, when you're in elementary and even middle school, being in your late 20s is forever in the future. And so, but also you don't think about the idea that you might not be there in that country. So I just assumed that would be my first eclipse, like my first total. So then after college, I went and did a PhD. And the thing that you normally do after you've done a PhD, and you can ask me about what my PhD is on if you want, but the thing that you normally do is a postdoc, which is kind of like you're working for a professor, but you're not a student anymore, and it's just a research job. And I took a job in Illinois. I moved to Illinois 6 weeks before the 1999 total solar eclipse, so I didn't get to see it. The original plan had been, because my husband was living in Paris for the 2 years up until we moved, was to actually go to northern France because that was a better option than the little bit of the UK that got to see it. But then we moved to the US, so I didn't get to see it. Then the next thing was, okay, there's an eclipse in southern Africa in 2001, and it was going to be on June 21st, so the winter solstice in the southern hemisphere, and around midday. And it was 2 days after my 30th birthday. So, like, okay, let's do that. Let's go and do that. And then we decided to get married, so we couldn't afford to do both. So I didn't get to see that one either. A year after that, we moved to.
Can I just make a comment on that? Because the reason my second husband and I took so long to get married was because we had eclipses in the way. We had the 2012 and the 2013, so we didn't get married till 2014.
Clearly, our priorities were wrong. And so then a year later, we moved to University of Missouri as professors. And when I got there, this was 2002, and Columbia, Missouri was on the path of the 2017 eclipse. And the local amateur astronomers, when I first met them, were like, you know, this thing is coming. They already had T-shirts. So this is 15 years ahead of time. And so basically, I spent the next 15 years preparing for the 2017 eclipse. And that was my first eclipse. So even though I was chairing the Solar Eclipse Task Force for the American Astronomical Society, and even though I was giving talks all over the place on how to view and how to be safe and all of these things, I had never seen a total eclipse until the 2017 eclipse.
Wow. Wow.
Wow. So I have a quick housekeeping. I'm getting a little bit of a peek from your input.
Yep.
Yep.
A little bit more.
Okay. Perfect.
This
All right. So what was your PhD work in, and what was your postgraduate work in?
Okay, so
Or your postdoctoral work? Yeah.
My PhD is on the mineralogy of dust around dying stars. So basically, when stars like the sun die, they go through like a red giant branch phase. And at that time, they start to lose a lot of material out into space, and it forms dust. And that dust is what goes on to be in the interstellar medium, so affects what we see out in space, but also is what forms the next generation of stars and planets. So I study the dust where it first forms.
Wow. And that was your
my
PhD.
So for that, it was mostly using spectroscopy. So where we're looking at how the different colors of the light, especially in the infrared, indicate what it's made of. When I went to do my postdoc in Illinois, I was working on looking at the distribution of dust. So it was more imaging and looking at how much light was being emitted or reflected from the dust so that we could see how much there was at different distances from stars.
Wow, that's amazing.
Yeah. It is the dust that you're basically seeing the next version of the solar system coming up by seeing the dust that's coming out.
Except that what goes into the solar system will be that dust from hundreds of stars. It's not just one.
Oh.
Yeah.
It is.
Yep.
Like hundreds of iterations of the same star, or dust getting collected as it
so basically you can think of it as being, within the neighborhood that the solar system formed in, there would have been a whole bunch of stars that were throwing out material, and all of that stuff coalesces together, and that's what makes the new star system material from, all the local stars that have died.
So those local stars, they would all be the same generation, or do you get multiple generations?
So it gets complicated because how long stars live depends on their mass. So the sun won't die for another 5 billion years. So about 10 billion years of life, right? But a star that is 2 solar masses will last for maybe 4 or 5 billion years. And a star that's 4 solar masses will last for maybe 2 billion years. And so you've got them being formed at different times and then throwing out material at different times. So it's lots of generations all at once.
Wow.
Okay.
Did you want to hit something, Leticia?
Well, yeah. Well, just I want to go back to the eclipses because that's who I am.
See, we are.
So I watched your TED Talk, and I'm now surprised to hear that you hadn't actually seen the eclipse before you did that TEDx.
I'm very convincing.
You were very
So by the time I did the TED Talk was actually on the Friday before the eclipse.
I noticed it was like, oh, this is
But
right
I've
before the
been
eclipse.
doing the outreach for the eclipse seriously, I'd been doing it for about 3 years before the eclipse. I
Yeah.
had lots of time talking to people who were, I was I was leading the task force, and
Right.
I understood the concepts very well. And I have a very good imagination.
I was able to get mine done in 2016, so a year before the eclipse. I was able to do one before then.
Yeah, it's fun. I'll talk about it.
So you saw the 2017. Were you able to see the other ones in between?
2019, I actually organized a
Really?
trip that was just me and my mom. She had Buenos Aires on her bucket list, and
Bucket list.
so we went to Buenos Aires, and then we went out to Western Argentina and saw it in San Juan province in Argentina. And so yeah, that was great. And so it was a very different experience from 2017, because 2017 I was literally broadcasting live on the local ABC station from a rooftop bar surrounded by drunken people, and it was loud. And then this place that
Yes.
we found, so I basically found a place on the center line, and we found one other family that had gone to the same spot, spoke no English, and I'm not very good at Spanish, and my mom just is too nervous even though she can speak it. And so it was very quiet and very different experience. My next opportunity was actually the 23 eclipse in Australia, and I got to be the eclipse expert for Travel Quest. So, one of these companies that organizes tours, they asked me to be on that trip, and it was great. And so that was on a beach in Western Australia, and that was really great. But again, different again, a very different environment, different time of the day, all the things. And so that was 3. That doesn't include annulars. And then because I'd seen the 2012 annular eclipse, I drove my kids from Missouri down to New Mexico for that one. And I bring that up because the next eclipse was the 2023 annular eclipse, which went over my house in San Antonio. So we did a lot of stuff for that here locally. And I ran an event on campus for that annular eclipse. And then 2024, I was running an event on campus as well. Unfortunately, it was mostly cloudy. And so we got glimpses, like fraction of a second of cloud clearing, but that was it. We got some fun being able to see the partial phases in 24, but not, because it was cloudy enough that you didn't actually need the glasses. And it was, so that was really fun. And I was basically emceeing the event. So I was just talking and telling people to look at things. But we didn't get to see more than, a glimpse of totality.
Yeah, for 2024, I emceed an event, and I probably will not do that again because it was just so much trying to explain it to the group and everything else. And I was like, I really want to just see it. So I'm not
It's hard to enjoy it.
And we're lucky enough to go during the pandemic. We both got into Argentina, and then we also got to Australia.
We had to fight our way in to Argentina.
We had a fighter.
Lots of probing and testing. Temperature checking. Yeah.
Temperature testing everywhere. Eating outside. We always had to eat outside.
Yeah. Funny. For your first one, your first total in 2017, were there any expected moments or any kind of expected emotions that you had during that first totality event?
I wasn't, and I knew what the stories were. I was live on local TV, and I was a little nervous that I might start crying, but I didn't. It was, honestly, I would say I found it a very chilled out experience. One of the things I've learned is that, if you want to center yourself and have a kind of place that you can go to that is like meditation, it's not really meditation. Mine involves what I saw during that eclipse. It's my memory of what that looked like combined with some other things. But it's very chill for me. It's like, oh, I'm just completely blissed out, enjoying what I'm taking in.
Yeah. So, since you have seen a couple of annulars, what would be your description of the difference between 99% and 100% totality?
I got into a pretty big battle with the Alamo over this for the 24 eclipse because they weren't on the path of totality. They were at 99.9. And kind of convinced them not to tell people to go there for the eclipse. And they weren't, and the zoo as well. And they weren't buying it. And it's like, people are going to be mad at you because the difference is huge. It's like, no, you either, it's binary. It's all or nothing. It's either 100% and you see everything, or it's not, and you don't have the same experience. And that's something that actually we put a lot of effort into in 24, was trying to get people to get to totality if at all possible, but trying not to discourage people from seeing it wherever they could be. So I didn't want to put people off if they couldn't get to totality of, oh yeah, just step outside and take a look. If you've got the glasses, or you can set up a pinhole or whatever, go and look at it. So getting that balance, but really trying to emphasize there is nothing like totality. And if you're 100 feet from where you think totality is, just make sure you're in it.
Yeah, they had that in 1925 in New York City, where they had all the students
Right,
lined up
exactly.
along Broadway at each side street. And I think it was like 96th Street or something like that, or maybe it was 96, where people on the south side of the street did not experience totality, and the students that were doing it and everybody on the north side of 96th Street saw totality. So it's like such a small 200 foot or 100-yard
The
window.
edge is the edge. The edge is the edge is the edge. I know San Antonio and Austin was that way too, because it was only parts of Austin that were in totality, and other
We had
parts
the same
weren't.
thing in Missouri in 2017, that it bisected both the big cities in Missouri, Kansas City and St. Louis. And in St. Louis, it meant that the Science Center and the Arch were not in totality.
Oh,
Wow. So let's go to the
Yeah.
Arch and watch the total solar eclipse.
99.
No,
Watch the edge.
Does
Watch
not
the
exist.
edge. Yeah. Although Chris had a really good shot of the annular, and he was kind of at the edge of it, so you could kind of
Yep.
see it roll around like the edge of the moon.
I think
Yeah.
it's one of those things where if you've never seen totality, go and see totality. But if you've seen a few, love the experience. Having different experiences is also nice. So maybe taking a chance on,
Yeah.
okay, I'm going to get a bit of difference by being on the edge instead of being right in the middle. In fact, for the 2027 eclipse, I'm not even attempting to get to the center line. I'm probably not going to be on the edge either, but I have my motivations. So
Okay. Oh, you're not going to be on the edge either?
no. So looking at where the path goes, southern Spain actually gets, because it's such a long eclipse, because if you're in Luxor, you're going to
Yeah.
get 6.5 minutes. Not
Right.
on the center line. And even if you're not at that longitude, you're still getting a decent time. So Rota in southern Spain, there's a US naval base there, and I have family that live in that town.
Nice.
But they get like nearly 2 minutes.
That's
on there,
good.
So
Yeah.
it'll be Spain 2 years in a row, but that's okay.
Spain's awesome.
Perfectly okay.
I did a pre-check I went this last year to check out sites where I wanted to check, and I finally got it finalized. And Chris and I are going to do an episode on that. But Spain is beautiful, and the people are so friendly. And I got by with my tour of Spanish, and I got to stay in Barcelona for about
Nice.
almost a month.
Yeah, we have our trip all
Although it's
No.
not going through Barcelona.
we have ours all planned out. And again, I'm not doing anything like an official tour or anything, but the way things are turning out, I think half my family is going to be where we're going to be. So
Awesome.
they're all just,
That's awesome.
It's actually just over 2 weeks before that eclipse in August is our 25th wedding anniversary. So we're going out before our anniversary and coming back after the eclipse. So we'll celebrate both.
That's awesome. That's
And
awesome.
how many
25.
years?
It's our silver wedding anniversary.
25.
25. That's a
Awesome.
lot. Yeah, from the missed one in, what was it again? 2002. For the missed one in 2002.
Yeah.
So you guys have been together even longer than that, right?
We've actually been together since 93.
Oh, wow. That's awesome.
Yeah. And at this point, it's like, totality, and he's only seen one and a bit. So we need to have another joint one.
Yeah, you need to do another joint one. Well, you could do joint two with
Yes,
two
exactly.
coming up. Yeah, that'll be great.
Eclipses give us a rare chance to observe the solar corona. And I'm curious if you can tell our listeners what you find out there to be the most impactful scientific discoveries that we've come across observing the solar corona.
Ooh, but it's the only way that we can make the connection between what we can observe as an everyday space observatory type of view of the corona and what the solar surface is doing. And so I think that it would be hard to pick one impactful thing. I would say that eclipses have given us so many opportunities to understand different things, whether it's about, it's everything from how the solar wind works. So, which we still don't fully understand, but being able to make that connection between what the surface is doing and what is flowing off the sun. And that has a huge impact for what actually affects us as space weather and that sort of thing. But also our own ionosphere and how it behaves, which is also important for telecommunications. And then there's things like, verifying general relativity. It's very, you've got these ideas that you have to be able to test. And it's amazing to me that within a few years of Einstein putting out general relativity, that we were able to test the concept with an eclipse. And so I think it's something that people don't often understand, that measuring things about the sun is hard, and that an eclipse provides us something that we can't do otherwise.
After Einstein's theory of relativity, there were actually like one or two expeditions to see the eclipse that actually failed before they actually got to the
World
one that
War I.
they were able to prove it out. Yeah,
Exactly.
one. It was
Right,
during
exactly.
World War I.
World War One was, well, depending on which country you were in, but yes. So the US version of the dates for both world wars are different than the European version of the dates, which is confusing to me. But yeah, so it was 1919 when we finally managed to get an expedition that worked. So
finally.
But yeah, I mean, you're not, being able to get those measurements, but then we continue to improve our technology. I mean, you think about everyday things that people use, like your camera on your phone, and how much digital cameras have evolved since the first digital cameras to what we now have. The same sort of technology is also impacting the level of detail that we can achieve in observations. So even though we might have got some information in the past, continuing to take observations with every eclipse is also important, because we have better imaging than we had before. And people also don't realize that making a filter that only lets in a certain color of light is not straightforward. How do you actually make light do that? And so, we are able to learn more with every single eclipse.
So I noticed that you're interested in optical properties. So I'm curious I'd love to hear your analysis and observations of the concept of shadow bands and how those propagate through the moments before and after totality. And if you've experienced them or if you've studied them at all, I'd love to know what you think about that.
I honestly do not understand shadow bands. It's awesome. Like I've read more than one and they don't quite intersect. And so I'm not sure that I believe that we understand them properly, because there's conflicting ideas.
Have you ever seen them?
I haven't. Yeah. It was something that we were trying to figure out how to do that in Australia, because that was, I think, going to be the best chance. Yeah. We never, just wasn't. I mean, I need to just carry a big white sheet around with me. Videos of it.
You have to.
Gordon. Yeah.
Yeah. He's
Good,
never
'cause-
been able to catch one on video.
I have zero interest in capturing these things.
Okay.
When I've been to eclipses and people are bringing all of their equipment and I'm like, nope, I just want to I want to watch it with my eyes. I want to take in all the things. I don't want to take any images. I don't want to take videos. Happy to talk about what I'm experiencing whilst I'm experiencing it, and point things out for people so they don't miss it. But I don't want to be distracted by technology while I'm taking in an eclipse. People, and maybe this will change when I've seen more, but right now I feel like there's still too many things for me to experience that I don't want to be distracted from that. Whereas, yeah, there's lots of people who, and usually they have seen quite a lot, and so maybe that's part of why they do the recording and stuff. And there was a guy in Australia who set it up so he got the reflection of the total in a cup of tea. And it was very cool. But I'm like, no.
Okay. That's a cool picture.
But you're wasting your time
Right.
setting up a shot instead of watching the event.
Well, he set up the shot
did.
beforehand and then just took a picture.
Yeah, hopefully.
Yeah.
But it's nice to have somebody just scream out shadow bands, and you start looking around.
That's
And then you look
basically
back up.
my job at a couple of eclipses now. It's like,
Yeah.
So how about animal
Right.
behavior and that type of thing? Did you get any of that in your
Certainly did.
experience?
What was interesting for me was just how much the general public really caught on to that aspect of things when I was doing outreach. And so I ended up talking about that more than some of my own expertise, because people are all excited about the idea of, animals. I was even on some show called Pet Talk, reassuring people that their dogs did not need eclipse classes.
Yes. They
They're
don't. They
smart
won't
enough.
look.
They're smart.
They don't look at the
Yeah.
sun to start. They're not going to look at the sun. Yeah. They blink away. Yeah. Right.
Is there any connection at all between the material science and dust and total solar eclipses? I think it's, the corona is what, like a plasma?
Right. So no, not really.
Not really.
So
Yeah.
nearly all the dust in the solar system is what we call the cause of the zodiacal light. So it's basically coming from where you've got asteroids and things, and as you get collisions on them, it throws up dust, right? And so you have this layer of dust that forms a distribution of very light dust in the solar system, but it gets blown out by the solar wind, and the solar photons. So the sun's light literally pushes the dust out, and so you really don't have anything close in. And so there's the place where it would matter would be where you are thinking about the interaction with an atmosphere. And so it may become important when you're thinking about just how the solar wind affects an atmosphere. And, for instance, like in Venus's atmosphere, it's very thick. So if it had dust in it, it would have more of an effect. But it's not really solar eclipse related.
Is that light primarily dust that's between Mars and Jupiter, or is it everywhere?
So it's primarily between Mars and Jupiter, but as it's being pushed out, it's going out through the rest of the system as well. Most people only think about it because it gets in the way. So if you're trying to observe something that's in the plane of the solar system, that light gets in the way of very faint things. So it's very hard to then observe faint things if the zodiacal light is very strong.
Wow.
Being outside of the plane of the solar system makes it easier because not much of it gets above like the main plane of the solar system.
Well, I'm curious. What in the hell is 3I Atlas?
I don't know. What is 3I Atlas?
Oh,
It's
the comet 3I Atlas that's heading out towards Jupiter. I'm curious because some people say, well, it's not behaving like a comet. And then they're like, well, it kind of is a comet. And so I'm just kind of curious if you've done any.
I have not looked into it at all. I think there's a lot of things.
Okay.
Comets are pretty varied. If you just look at the pictures of things that amateurs have taken, like the colors change, and they're hugely, they vary hugely, and they could be anything from, from the Kuiper belt, so out by Pluto, or they could be coming from further out in the solar system, and then that affects what properties they have. So I think sometimes people have overly idealistic views of what a comet is. God, I regard Pluto.
But this one comes from outside of our solar system. It's come in from a trajectory. It's clearly not an Oort cloud type visitor. And so it's just been interesting to hear the different astrophysicists go about.
We form a lot of stuff out in space and it's cold. So sooner or later, you're going to have something that is going to come past us and be pulled in a little bit. And this isn't something that's being captured by the solar system. It's just going past us.
Mm-hmm. Just a visitor.
I want to go back to the outreach you've done, and then you were teaching at the same time you were doing your outreach, right? Okay, so I want to know what your students thought before and after the eclipses.
That's interesting because for the 2017 eclipse, it was the very first day of classes. It wasn't like it was partway through a semester, so I'd have a class, and a lot of them were, I had students who were brand new on campus, and so that one, there weren't that many students that I could be like, so what was your experience? I'd hear actually more professors than students that were all just blown away, right? They were like, oh, we're excited, and then it can't be that impressive, and then just like, so 2024, because we were mostly clouded out, actually what I was impressed about was just how much everybody seemed to enjoy it, even though they didn't get the full experience.
That's good.
Darkness.
That's good. It's just the total darkness impact. Yep, total darkness. Yep. It was. I did have a local here in Dallas. We had Brookhaven College had an astronomy professor, and she finally saw her. She'd been teaching for 30 years, and she finally saw her first total eclipse, and she goes, "How have I made it this long in astronomy? I've never seen a total solar eclipse. It should be part of the curriculum to go see one."
Well, if only that were practical, but yes.
I know it's a little unpractical for a lot of people. But
yeah, certainly we made sure that everybody was excited locally. At least one of my students managed to see it because they weren't on campus.
Well, I noticed at our AAS meeting in San Antonio, there were like 4 or 5 young people that were helping out for the conference, and they were like, we're the next generation to be leading this stuff. They were just so pumped and so excited about it because they'd seen the 2017.
Right. So you've got...
And now they're doing the 2024. Exactly. Yeah. So this whole new generation of people that were going to be excited and carrying on the legacy of being a multiple eclipse person.
Right. And, some of them hadn't seen 2017, or at least they'd only seen it as a partial because they were based in Texas. Oh. And some of them were like, no, we know we need to take this on, even though we haven't seen one yet. And that was pretty impressive. It is important because the next U.S. mainland eclipse is nearly 20 years away.
Yeah, I know. It's 24.
Hopefully they will still be in the field and able to do stuff. So.
Well, I was part of the Kate effort I did for Kate. And that was the young people that I met during that. It was just, so heartwarming. I really felt of a lot of things that I've done in my life. That was one of the big things that I really will change the future, was the outreach I did for Kate.
So we were involved with that, but I had one of my grad students be the lead person for a site near Uvalde. Okay. So, and the same thing happened in 2017. So there was also Project Kate in 2017, and it was one of my grad students who worked with 2 high schoolers for the observations that we took for that iteration of Kate. So I think it's been a very successful citizen science type of thing, but it's also, I think, helping the next generation of science professors, especially astronomers, to be more literate with the public. That is, their ability to connect with the public is going to be better. And let's face it, we need that. history of
Yes,
this
we
country
do.
where there is a lot of science denialism, and we need to have scientists who can do that.
So, what were some of the results of the Citizen Science Project from 24?
I could show you pictures. I have to look them up though.
Well, we could do a screen share. It'll be our first screen share. So try
Let me
it.
see. I'm trying to see if
So
I
again,
got that.
I haven't been involved with the data reduction. I don't know how far along they've got. I know that they were very successful in acquiring data, but I don't know what they've done with it in terms of publishing. And there's stuff still coming out from the 2017 data.
Wow.
This the thing is, as you learn more, you
Actually-
can go back and reanalyze old data. That's something that we do all the time.
And they were using
That's right.
polarized
So
filters.
that was a big difference.
And Chris, we just need to go ahead and have somebody just talk about Kate
Oh yeah.
for one of our podcasts.
Okay.
We need to do a big podcast on just Kate, what we found. Maybe I'd love to interview some of the people out of Camp Texas, the young people out of Camp Texas that were just amazing.
But if you want to know the results, I would reach out to like Amir,
Oh, and I was got probably bring Amir in.
because he would be,
For that.
and he's an excellent presenter.
Yeah.
But
Yeah,
the polarization stuff, you're picking up different information by using the polarized light, whereas the original Kate was 2 different colors, but not what polarization was doing.
Yeah. Well, I'll add that to the list, Chris.
Well, what do you find to be the biggest misconception about eclipses? And perhaps how to debunk such
Okay, the
misconceptions?
biggest one is that you must not look at the total eclipse.
It's hard to communicate the
Exactly.
differences, though, because everybody's like on or off, and like, no, you use the glasses during partial, take them off for totality. And I preached that for years, and sure enough, I had a couple friends tell me, I go, I didn't know I was supposed to take my glasses
So
off.
but that's what I mean. Is like there is this abiding myth that, if you take your glasses off, you'll be blinded.
Yeah.
And we've got this safety information that is endorsed by NASA and NSF, but also various optical and optometric and ophthalmologic societies. And they're still like, no, you're irresponsible. You shouldn't be telling people that. It's like, okay. And this is, again, coming back to the issue of people not believing expertise. That's hard. In the current climate, people don't want to believe it. There's not a lot you can do. But it's definitely just getting out into all the places and trying to just keep repeating it. But I think it has to happen every single time. So, in some ways, doing an annular or a partial is easier because just keep the glasses on all the time.
Yep. It is easier. And then if you have clouds.
Right. I mean,
because our annular was down along the river, and it was cloudy practically the whole time. It did clear up a little bit where I had to have the glasses for like 1 or 2 minutes of it, but most of the time it was cloudy.
So it was like a bit cloudy at the beginning so people could see it through the cloud, but then it cleared up. So then they could really enjoy it without having to keep worrying about whether to take the glasses off or put them on.
Yeah.
That cold front came through Texas, and it was clear as a bell. It's about 100 miles north, and it was clear the whole event.
Yeah.
And Leticia's like, I got these great pictures through the clouds. And they're like, well, I'm happy for you. I got clear skies.
I had clear skies.
Not going to brag. Everybody's got different experience.
Right. But yeah, coming back, there are definitely, other things that people have ideas about, like what animals are going to do, or that, oh, no, the animals won't react, or that sort of thing. I think that's the one that people are most surprised about, is the idea that the animals react. Not so much that it's a misconception, but that it really surprises people. So I think that's part of it. There's definitely some other weirdness to do with, just weird ideas about what you're actually looking at, and is it a black hole and things like that.
There's a song called The Black Hole Sign.
I think it predates that. It predates. I remember going to see the Disney movie, Black Hole, and that was the late 70s. And
something like that.
That's what a black hole looked like. They had this thing that has like swirling material, but from the point of view of what you're seeing, when you see an image of, a total, and you're seeing the white corona and then the black in the middle, It looks kind of like that. It's not completely out there to say, that looks like a black hole. And even with the current images that we're getting of black holes that, are really technologically impressive, still, it's like, I understand why people might perceive it that way. Oh, yeah,
You have the dark sky, but it's not completely dark. There's some blue hint to it, blue tint, and then you have the black
exactly.
of the moon blocking out the sun. That is the darkest black you'll see against a steely blue sky. It's mind blowing to see that
is.
dark of a black hole in the middle
Especially
of the
with
sky.
the corona around it. Especially with the
Exactly.
corona around it. Backlighting it well.
Yeah, that's the good stuff.
Did you want to take a break?
Yeah, let's go ahead and take a break and then we'll wrap up here. We've been going for 50 minutes, so maybe 45
okay.
minutes
Well,
of good stuff.
all right.
But yeah, we'll stop it and we'll start again.
So you're working with students and they're taking are you teaching were you teaching astronomy 101, 102, 301? What level of astronomy are you teaching?
So I teach across all levels because it's a physics and astronomy department. I mean, there's physics in all of the astro courses too, but so I'm trying to remember. I don't remember department chair. I didn't have to teach every semester, so I don't remember what I was teaching during the semesters that we had eclipses. But I've taught across all levels, so from the intro non-majors to graduate level.
Okay, well, for the kids that are dreaming of the stars and dreaming of a career, what is the one mind-blowing fact about the sun, the moon, the solar system, the earth that still gives you chills?
That's tricky. So the one mind-blowing thing about something in the solar system that I think it's that there's still so much we don't know. So it's not so much that we've learned, it's that there's so much we still don't know. We're still sending probes out to, different icy bodies and things like that. And it's amazing that we still have a lot to learn.
I just saw my first picture of the poles of Jupiter. And the stable storms down there on the bottom.
Yeah,
something like that. It was just the coolest picture, and it looked like it was like a stable storm on both ends of the poles. And it's like, and there's theories that there is life in Jupiter because it's all carbon. There could be life there living in the clouds and in the storms. And I was just like, oh my God, that would be like a little continent at the bottom of the poles.
Some kind of irradiated life form that survives on
well, I think,
radiation. So
I was going to say, it depends on how you want to define life as well, because, you can imagine there could be something that's very different than, and so I don't know if either of you, which the movie comes out this year as well.
Soon, I know.
But that whole concept of there's this life form that you can communicate with, and it's I think the chances of there being intelligent life elsewhere in the solar system is unlikely. But some sort of life, I think, is not completely silly.
I don't know. We got intelligent life here, so we think. We got intelligent life here. I don't think we're that special. At least I hope we're not.
So I think that my argument I agree that there should be intelligent life elsewhere in the galaxy. But I think within the solar system, the communication possibilities mean I think that we should have found evidence for them already, or they should have found evidence for us and reached out, or whatever. That if we're talking about an intelligent life form within the solar system, I feel like that
dolphins haven't made hospitals in like the oceans of Enceladus or something like that.
I mean, if it's a very different type of life, yeah, sure. Maybe it's something that we wouldn't have communication with.
And plus, it's our definition of intelligence too. That's the difference. Also, to keep that
again,
in mind.
I think that is the idea of what it means for something to be sentient. We have, I think, a pretty good definition, which is, do you use tools? Which I think means that crows are sentient, but, tools
Yep.
are.
Well, back on Leticia's observation, the hexagonal formations of the storms at the poles of Jupiter.
No idea.
Yeah,
That's
why?
a whole other paper.
That's current research.
It's
I mean, that's
wild.
like understanding,
I know it's current.
why you get these things as a stable system. That's going to be the people who are studying that. There's a whole lot of having to do models of hydrodynamics of what the system and all of that, and then understanding what so like even just for the bands. If you think about what Jupiter looks like in its classic view, and it has like the stripes, the different colors are different.
It's not like a sphere. It's
Exactly.
different. Yeah. Yeah, I think I think we're going to get a lot. Like you said, the thing about the solar system is we don't know that much. There's so much more to learn. There's so much more to learn. Yeah, so much more to learn. With our new optics, with the material science, the development to material science that we can actually get deeper into the atmospheres now. And I think 3D printing is going to be a big thing on it because everybody's going to be able to make their own little spaceship soon. Just pull plans down from the internet, make your little spaceship. Just send
it. They're not going to get very deep into a planetary atmosphere, though. So
no, they'll still be sending their own stuff.
I mean, there's a lot of really cute stuff going on with like CubeSats and having students developing things that you can do so much now, with the various companies that then service the space station and things like that, the opportunities to put things into space are much more common. So I think there's a lot that we're going to learn in the next few decades.
I think so too. And I still hope to retire on the moon. We'll see.
Yeah, I don't think they'll have a good base there for a few decades yet.
I know. I think it's going to be a few more decades too. But I plan to live to 105, so who knows?
It's the plan. But you need that magnetism of Earth to keep you bound.
There's lots of dirt.
That's why I'm not sure Mars will work out too well for humans. I'm not so sure about that. No magnetic field.
If we want to go into some of the sci-fi books I've read, it's we're going to just throw a bunch of icy rocks at it for a while and build up the atmosphere eventually.
Right, but if the atmosphere is just like the Earth's, it's not going to help you. It's going to get eroded. Yeah,
pulled off.
The only way is to get it really dense, like Venus, and because Venus doesn't have a magnetic field, but the atmosphere is so dense that it protects itself.
I didn't realize that.
So yeah, magnetic field is
so the gravity's strong enough to keep it in.
It's not the gravity,
and the solar will blow it out.
Yeah, so it's not exactly the gravity. It kind of is, but it has an ionosphere like the Earth does, where up in the upper atmosphere, whether you're talking Earth or Venus, the particles are high enough up that the sun's interaction means that they're charged, right? They're ions, but it's so much denser on Venus that deflects wind, that the charged particles in the ionosphere, if it gets as far as the ionosphere, it's going to make it down to the ground because the atmosphere isn't as thick.
Okay. Let's just learn something new. Thank you.
Yeah, I'm full of these.
Shall we wrap up?
Well, yeah, but let's we talked a little bit about 26 and 27, but plans you have? Is it going to be Spain both times for 26 and 27?
So we already have the plans in place for 26. We will be in Oviedo, which is north from Madrid, more or less, almost at the coast. That's where we're staying. That's where we have a hotel. But there's an easy journey up to the coast from there. On the train and the weather on the coast. So it's going to be Gijón, which is on Gijón, I guess, which is on the coast. So that's the plan. And I'm not doing anything except for providing glasses for my family because my mom and her sister and my dad and my stepmom are all coming out. So,
It's
and
good.
then
Well, I'm actually doing a the family plan like you are, but I am providing like an eclipse camp. I've got 10 rooms with air conditioning, which is apparently a big deal. It took me forever to find those.
Yeah.
And we're going to be between Zaragoza and Terrell, because when I did my trip through, I would find one place, clear skies, next day, clouds on the horizon. So I want to have running room just in
Fair
case.
enough.
Yeah. So that's what I'm planning on doing. And I've got like I said, a hotel with air conditioning, so everybody will be comfortable. I'm going to have some snacks and everything else for the whole eclipse, and then we'll have dinner back at the hotel.
Cool. Well, if you had unlimited resources, what would be your perfect viewing experience? What would it involve and include that you don't see elsewhere?
Theatrical, because I've always had to do things on a budget, so it's always been what is achievable. But honestly, just having the space to enjoy. Again, this comes back to me not taking photos. Like, I just want people to see it. I and I want them to be safe. And so just having enough glasses for everybody, have a sound system so that you can tell people, okay, look at this now, look at that now, take your glasses off, put your glasses on. Um, uh, you know, and then having the entertainment, because it's a long process for the partial phase, having some entertainment along the way. And that's all it needs to be. I think it's the staying entertained while the partial phase is going on is the hardest.
Yeah. Yeah.
I'm not going to worry about that so much.
So much fun.
They're going to have to entertain themselves.
A lot of waiting, but I've got an idea. Just popped in. On your glasses, you've got the warning, do not look at the sun. And then across the tide, really big, it says, move during totality.
I think most of them say that.
I think at this point,
most of them say that.
And there's a lot of stuff out there. There's cartoons. There's all sorts of things. But yeah, I mean, but that's why I think it's good to have someone or some way to say, okay, glasses off, and then having someone who's doing a countdown to, okay, now it's like, time to drink, put your glasses back on.
Glasses on. Yeah, and if you have a group, you've usually got somebody that's screaming out. But
Exactly.
having a microphone is pretty good.
But I think, doing that on a really big scale, and especially for kids so that they get excited, that's my idea, because the sort of tours are very expensive.
Well, I'm taking a lot of glasses with me, so I'm going to be passing them out in some of the smaller towns and things like that. I had quite a few left over from 2024, so they're going with me.
I'm actually going to do some talks in London because London gets 90%. And so I'm going to be giving some talks in London when I go visit my mom in April. So,
wow, that's great. I have one more question to ask.
I've forgotten what it was. Sorry.
It has something to do with the eclipse tattoo.
Oh yeah, your eclipse tattoo. How long did that take? This is awesome.
But it's not something that was done all in one sitting. Done, and then some shading was done, and so on. And actually, when it's finally done, there'll be a nebula underneath this.
Awesome.
So but yeah, and this is a whole sleeve that's a work in progress. So it isn't something that's happened like, oh yeah, that's when that appeared. There's certainly a lot of hours of work gone into it, but not all at once.
Yeah. Do you get to add to it when the eclipse season comes around, or is it just kind of a random that you do your future work on it?
So it's more that you let it heal and then you do the next bit and it'll last longer that way. And so it's more timing of when I have time and when the tattooist has time. And for reasons of politics, I haven't been to see him in a year because I don't want to talk to him.
Silence is golden.
Yeah.
Well, this has been great. This has been a fun time.
This has been good. This has been
I
good.
feel like I didn't
Yeah, I think
answer
we have
some
a
of the
lot of-
science questions, but
Oh, we nerded out on the science
Yeah.
questions.
Yeah.
Okay. Thank you so much
No,
for your
no.
time, Angela.
All Well, that's it for this episode of Totality Talks. We will be publishing this episode on the day of the lunar eclipse across North America. Hope you were able to get up and observe the event from your location. If you like what you hear, please subscribe, rate, and review our podcast. As always, clear skies.